Hello everybody, welcome to Solving Radical Equations. So we've done quite a few things, right? We've learned a lot of the rules of exponents, we've learned how exponents and radicals interact, we've taken the nth root of things, we've even looked at graphs and figured out what those, like how those change, we've transformed them, we've written equations for them, we've done a bunch of stuff, right? Today we're going to actually just solve radical equations. We're just going to just jump straight into some algebra. All right, so today's learning objectives are solve radical equations, including checking for extraneous solutions. We'll go over what that means. Use algebra to rewrite formulas, and then solve inequalities containing radicals. Now, solving inequalities containing radicals is usually just word problems where we have to interpret things, right? That's typically how inequalities work. Okay, so solving equations with radicals. Let's start off with a pretty simple one here. So if we have, this isn't like a negative sign, this is just like, well, get rid of that so it's less confusing. But so we have x plus 5, the square root of x plus 5 minus 1 equals 3. So the first thing we're going to do is we're going to isolate the radical, right? I'm just going to put this back. So the first thing we're going to do is isolate the radical, right? So in order to isolate the radical, we need to get rid of this negative 1, because this negative 1 piece right here is the only thing standing in our way, right? So if we get rid of this negative 1, we would just have the x minus 5. So we're going to just add 1 to both sides, pretty straightforward. We'll get x plus 5 equals 4. And then what we want to do is to get rid of the square root, we're going to square both sides, right? The square root would be like n equals 2, right? There'd be like a little 2 here. So in order to get rid of the square root, we square both sides. So when we do that, we get the square root of x plus 5 squared equals 4 squared. And then, of course, the square root of x plus 5 squared is just x plus 5, right? Those two things cancel each other out. So we'll get x plus 5 equals 4 squared, which is 16. Just subtract 5 from both sides, and you get x equals 11, right? So essentially, the trick to this is you want to isolate the radical first. You want to get everything out of the way so that all you have is the radical, and then take the square root or cube root or whatever root you have to take that of both sides, right? Or in this case, you'd have to square it, right? Because you'd be getting rid of the square root. So you'd square both sides, cube both sides, whatever you need to do, right? And then just kind of simplify from there. All right, so let's do this next one. So for this one, we have the cube root of x plus 2 equals 4. All right, so what are we going to do first? We have to isolate the radical, right? So we have plus 2 here. We're going to subtract 2 from each side and get rid of it. So that'll lead to the cube root of x equals 2, right? Because 4 minus 2 is 2. And then to get rid of the cube root, right, we have to cube both sides. Does that make sense? So you square both sides to get rid of a square root, you cube both sides to get rid of a cube root, you take the fourth power of both sides to get rid of a fourth root, right? You have to make sure that your n equals the number that you're trying to get rid of. So we'll cube both sides essentially, and you'll get the cube root of x cubed, which is just going to all cancel out to make x, right? And then 2 cubed, which is 8, so we have x equals 8. All right, so go and try this one for yourselves. So we have the square root of x minus 2 plus 3 equals 5. Go and give that one a shot. Pause the video, and we will come back and do it together. All right, welcome back. Let's go ahead and do this problem. So square root of x minus 2 plus 3 equals 5. First thing we're going to have to do is get rid of this 3. We're going to have to isolate our radical. So minus 3 for both sides. But we get x minus 2. I don't know why I wrote 12. So we have x minus 2, the square root of x minus 2 equals 5 minus 3, which is just 2. Right? And now we can square both sides so that these cancel out, and now we'll get x minus 2 equals 4. And our final step is just going to be to add 2 to both sides, and we're going to get x equals 6. That's it. Now, this was a very basic one, right? But it kind of taught us the skill. So it taught us that we can undo a square root by squaring something. We can undo squaring something by taking the square root of it. It's kind of the opposite. All right. So let's jump into a bit of a word problem here. All right. So the suspension cables from the Golden Gate Bridge's towers are farther above the roadway near the tower and closer to the roadway near the middle of the bridge. Okay, so that kind of makes sense from an intuitive perspective, right? Like if we have a tower here and a tower here, the bridge kind of goes like that, right? So it's higher up near the towers, it's closer to the road near not near the towers, right? I mean, that makes sense. All right. The following is an equation. The following is the equation is height of a cable y at distance in feet x from the center of the bridge. In other words, so what x represents here, right? If we have the center of the bridge, which would be like here, let's say, right? X is the distance away from the center, right? And then y is like how high is it to hit the bridge, to hit the railing, right? Okay. How far is the cable from the road when you are 200 feet from the middle of the bridge? So in other words, if I've gone 200 feet this way, right, how tall is that point? That's what we're looking for y, right? Okay. So this is our equation. X equals the square root of y minus 220 over 0.010583. All right, fun. So let's go ahead and do it. So first of all, we're trying to find the height, right? We know that x is going to equal 200, but we need to find the height where x equals 200. So we could either plug in a 200 here for x and just solve for y, or we could do, which in my opinion makes more sense, is let's just solve for y in terms of x, and then just plug x in at the end, right? That way we don't have to plug in all these huge numbers and work with a bunch of stuff. So let's just solve algebraically for y, and then once we solve for y, let's plug in 200 for x. I think that's a reasonable approach here. So the first thing we have to do is isolate the radical, right? So in other words, if we're dividing both sides, or if we're dividing by this 0.010583, right? If we multiply both sides by that, it'll isolate our radical, right? So let's go and do that. So we're going to get 0.01053x equals the square root of y minus 220. Okay, so far so good. So let's go ahead and get rid of the radical, right? And because this is a square root, we have to square both sides. So we have to square both sides over here. And so now when we square both sides, we're going to get this number. I already kind of did the math ahead of time, so just trust me. So 0.010583 squared is 0.000112. And then of course x squared is just x squared, right? That's not too challenging. All right. So, and this is of course going to equal, we did all of this to get rid of this radical, right? So this is just going to equal y minus 220. And now to solve for y, we're just going to add 220 to both sides, right? So our final equation, if we solve for y, is y equals, I'm just flipping it so the y goes first, y equals 0.000112 x squared plus 220. All right? And now the question is, when you plug in x for 200, what is y, right? So really what we have to do to solve this problem is just do y equals 0.000112 times 200 squared plus 220, right? And I'll just kind of like tell you the math here. This ends up being like 24. This here is like 24.48. Right? Oh, it's 20.48, sorry. This ends up being about 20.48. So when you get 20.48 plus 220, you're going to end up with 200. 224.48. Okay. Yeah. So I guess this is actually just the 4. My bad. I was kind of going backwards here. So this would just be 4.48, right? Yeah. Okay. So yeah, if you simplify this, you get 4.48 and then plus 220. And this will give you 224.48. The point is that we rearranged for x and then we plugged it back in, right? This is just a calculator thing. So when we plug in y, or when we plug in 200 for x, we're going to get 224 for y. What does that mean? It means that at 200 feet away from the center of the bridge, up here is going to be exactly, well, approximately 224.48 what was it, feet, yeah. So that would be our answer, right? This is how far away it is. All right, so just a fun in the middle of the lesson word problem. But the real purpose behind this is being able to rearrange this formula, right? Using the algebra to be able to solve for that. All right, extraneous solutions. So extraneous solutions, we talked about it in our objectives, right? Solve for radical equations, including checking for extraneous solutions. I'm going to not only show you how to solve for these, but I'm going to show you exactly what the extraneous solutions are and why it makes sense that we have to do this. Okay. So first of all, let's just take an equation kind of like we had before, right? We're going to solve for x, okay? So we have the square root of 3x minus 2 equals x minus 4. So the first thing we would do is we already have the isolated radical, right? So we're just going to square both sides, and that's going to give us 3x minus 2 equals x minus 4 squared, right? So 3x minus 2 equals x minus 4 squared. If you FOIL x minus 4, right, you'll get x squared minus 4x plus 16. So the minus 4x's will add together, right? So x minus 4 squared is x squared minus 8x plus 16, right? If you need to pause the video now and like just FOIL this yourself so that you see it, please do that, okay? But this is what you end up getting, right? 3x minus 2 equals x squared minus 8x plus 16. So now what we're going to do is we're going to try to set this equal to 0 because we have a quadratic formula or quadratic function here. So if we get rid of the 3x and the 2 on this side and move them over here, then we can set this equal to 0. So if we subtract 3x and we add 2 to both sides, which is what we did over here, this will end up equaling 0. So 0 equals x squared minus 11x plus 18, right here. And then once we're here, right, we're gonna factor using trinomial factoring. So we'll notice that x minus 9 and x minus 2, right? Because negative 9 and negative 2 make negative 11, and negative 9 times negative 2 is 18. So this will trinomial factor into this, which means that x is going to equal, when we set these both equal to 0, x will equal 9 and 2. Okay, so we basically all we did is we did the algebra from the little bit of algebra we learned today, combined with a lot of the algebra that we learned in Unit 3 and 4, right? Or unit 2 and 3 for the most part. So we're going to use it all year. So this is basically just the algebra there. So now what we're going to do is we're going to take these answers, right, 9 and 2, and we're going to check for extraneous solutions. And the way we're going to do that is we're just going to take 9 and 2, and we're going to go up to the very top, and we're going to plug them in there, right? In other words, where we have 3x minus 2, this is going to be 3 times 9 minus 2, right? And then x minus 4 is going to be 9 minus 4. And we're going to do that for both 9 and 2. So let's go ahead and try it. So on the left here, I've went ahead and done that. So 3 times 9 minus 2 equals 9 minus 4, which equals the square root of 25 equals 5, and the square root of 25 does equal 5. So 9 is a viable answer, right? 9 makes sense. That works. But if we come over here, we get 3 times 2 minus 2 equals 2 minus 4, right? 3 times 2 is 6. 6 minus 2 is 4. So the square root of 4 equals negative 2, and it doesn't, right? The square root of 4 equals 2. So this doesn't work. 2 does not work as an answer. So 2 is what is known as extraneous, right? 9 is the proper answer. 2 is extraneous. And now let me show you why that happens, right? It actually all comes down to this first step. When you square both sides, you actually produce the potential for these extraneous solutions. Now sometimes it happens and sometimes it doesn't, right? Sometimes both answers work. Sometimes they don't. It just depends. So I'm going to show you on a graph why this happens. So if we take this original part, right, 3x minus 2 equals x minus 4. Remember that on a graph, if you plug in both sides of the equation, wherever they intersect, that's going to be your x value, right? So let's do that. So 3x minus 2 equals x minus 4. I've got 3x minus 2 and x minus 4 up on the graph for you right here. And you'll notice that it looks like they cross at one spot where x equals what? 9, right? Well, we found out during the answers that 9 works, right? So then where is this 2 even coming from? Like, if we just plug these into the graph, right, and we just use the graph to solve it, we would have done this in 2 seconds, right? But you'll see that the answer is 9. So how do we even come up with this 2? Well, like I said, when you square both sides to get rid of a square root, sometimes you can create extraneous solutions, right? So what I'm going to do now is, what about this step where we had the 3x minus 2 equals x minus 4 squared, right? Let's do this. Let's take the step after we squared both sides. So if I do that, I'm going to get rid of these two. We're going to get a different looking thing, right? So this is a We have a parabola and we have a line. And a parabola and line will almost always create two solutions, right? So the first solution here is 2, right? X equals 2. Guess what it's going to be up here? Hopefully you already know. It's 9, right? Up here, we have E. It's not going to give it to me, but it's 9, right? So, there we go. 9 and then 25. So, we notice that on both of these, right? If I highlight these ones as well, right? I know there's a lot of stuff going on, but let's just look at the intersections, right? Here we have an intersection between the green and the purple, right? And this one is 2, right? But you'll notice that when we get the red and the blue, right, we have a solution of 9, and up here with the purple and the green, we also have a solution of 9, right? So 9 is a viable answer, 2 isn't. And the reason why is because of that specific step, right? I've just kind of proven to you that when you square both sides, right, to get rid of a square root, you can sometimes create these extraneous solutions. So anytime mathematically, for the rest of your life basically, if you square both sides of an equation to get rid of a square root, you have to check for extraneous solutions, okay? Because you could just get stuff that doesn't exist. All right. So, solve equations with rational exponents. Now, rational exponents, of course, just means fraction for the most part in math, and then exponents, you know what those are. So, let's solve for x, and let's take the equation x squared plus 5x plus 5, all of that raised to the 5 halves equals 1. Okay. Now, just like before, right, where we found a way to like cancel out radicals by taking the square of both sides, right? We got rid of square root by taking the square. Well, if this whole equation here, or this whole piece of this equation, this whole expression, is raised to the 5 halves, if we could get rid of this 5 halves, we would be in good shape, right? Because we could just factor, right? So the way we can get rid of this 5 halves is by multiplying this whole expression by an exponent. I guess multiplying by an exponent doesn't really make sense, but we're good. This 5 halves piece, right? If we can turn this 5 halves into a 1, then we're good, right? So what we're going to do is we're going to multiply 5 halves by its reciprocal. In other words, 2 over 5, and 2 over 5 times 5 over 2 equals 1. So if we can raise both sides of the equation to 2 over 5, that'll get rid of this, right? So let's kind of go through this. So we cancel the exponent by raising both sides to the reciprocal power. In other words, if I have x squared plus 5x plus 5 to the 5 halves, and I raise that whole thing to the 2/5, and then I also raise 1 to the 2/5, right? Because they have to do the same to both sides. You'll notice that the 5 halves and the 2/5 are going to equal 1 when they're multiplied together. So what this is going to do is this is going to become x squared plus 5x plus 5 to the first power. In other words, it's going to kind of get rid of the exponent, right? Because anything to the first power is just itself. So when these multiply together, they kind of cancel out, right? So x squared plus 5x plus 5 equals, well, 1 to the 2/5. It doesn't matter what you do to 1. 1 times itself, divided by itself, to the square root of itself, right? It's always 1. So 1 to the 2/5 is just 1. And now to solve this problem, right, we're just going to have to solve for x, right? So now, in order to get this to solve for x, for a quadratic, we need to set it equal to 0, right? So we have to subtract 1 from both sides. So we'll get x squared plus 5x plus 4. This can trinomial factor into x plus 4x plus 1, right? Because 4 plus 1 is 5, and 4 times 1 is 4. And so we're going to get x equals -4, and x equals -1. Now, do we have to check for extraneous solutions? Well, yes, we do. And the reason why is because what is 2 over 5, right? We multiplied, or we raised both of these to the exponent 2 over 5, right? Well, 2 over 5 is the same thing as raising it to the second power and then taking the 5th root, right? So essentially what we're doing is we're using that. I know this looks like we're kind of doing a lot in one step, but we could have rewritten this whole problem as this, like, squared to the 5th root, right? And then just done all the stuff we did before. But it's actually easier with rational exponents when you're doing both of those functions simultaneously, right? Or both of those operations. If you're doing both those operations simultaneously, this fraction is a lot easier to deal with than the square root symbol and the exponent at the same time, right? But you can see that what we're doing is we are taking an nth root and we are raising something to a power, right? That's what this 2/5 is. So yes, there is the potential for extraneous solutions, right? So anytime you deal with squaring the square root or cubing the cube root, right? And anytime you deal with these rational exponents, you really have to be careful, okay? So let's go ahead and just plug this stuff in, right? We said -4 and 1, or -4, -1. So if we get on here and we plug in -4 for x across the board, right? You'll get 16 minus 20 plus 5, right? To the 5 halves, right? Which gives you 1 to the 5 halves, which is just 1, right? So the -4 works perfectly. And then if we do -1, you're going to get the same idea, right? You'll have 1 minus 5, right? 5 times -1 plus 5 equals 1. And so we get 1 to the 5 halves equals 1. So -1 also works. So in this case, we didn't actually create any extraneous solutions, but you still have to check, right? Because you sometimes this will happen and sometimes it won't, right? But if you don't check, you're going to get answers that don't make sense. Okay. So the final kind of situation we can run into, right? And this is one of those lessons, guys, where you're just going to have to do practice problems, because I can't give you every single small interaction that could occur when you're doing these algebra problems, right? There's so many different possibilities. You just have to practice it and play with it. That's really all there is to it. All right, so if we have equations with like two radicals, right? What we're going to do is we're going to try to isolate the radicals one at a time, and you just got to keep working it, right? That's really all there is to it. It's kind of like when you factor and then add them together and then factor again and add them together, right, to keep reducing it as much as possible. That's kind of what we're going to be doing with radicals, right? So let's solve for x. So let's say we have x plus 9 minus the square root of x plus 9 minus the square root of 2x equals 3. All right, first we're going to isolate one of the radicals. So I'm going to add the square root of 2x to both sides, right? Which will just put this over here, right? So we'll have the square root of x plus 9 equals the square root of 2x plus 3. Right, now, if we were solving for this and we were just trying to find x over here, we would square both sides, right? So that's what we're going to do. So we're going to square both sides, right? So we'll have 2x plus 3 squared, right? So x plus 9 equals 2x plus 3 squared, which is the same as like the square root of 2x plus 3 times the square root of 2x plus 3, right? Because if it's squared, it's times itself. And now we're going to have to FOIL these, right? And I went ahead and broke this one down for you because the foiling is a little bit more complicated, right? So you have the square root of 2x times the square root of 2x is just the square, like it's it times itself, right? So it just gets rid of the square root symbol. So that's just 2x, right? And then here, we're going to have 3 times the square root of 2x, and then 3, excuse me, and then we're going to have 3 times the square root of 2x, right? So we're going to have 3 times the square root of 2x plus the 3 times the square root of 2x, which is just going to add together, right? Remember how in the last lesson we talked about when you're adding things with radicals, as long as the powers are the same and as long as everything inside the radical is the same, we can just add the numbers in front as if they're variables, right? So imagine this is 3x plus 3x, it's going to be 6x, right? And then of course 3 times 3 is 9. So we're going to combine like terms, and now we're going to have x plus 9 equals what we just simplified, right? 2x plus 6 times the square root of 2x plus 9. And now we have to isolate the other radical. So we got to move everything here over so that way we can get this 6 times the square root of 2x by itself, right? So I'm going to subtract 2x and 9 from this side, right? I'm going to get rid of this 2x and I'm going to get rid of this 9. And that's going to equal the 6 times the square root of 2x. So what this is going to do is give us x minus 2x is just negative x, right? And then 9 minus 9 just cancels out. So negative x equals this, right? The 6 minus the square root of 2x. And now what we can do is, well, if we want to get rid of the radical, we have to take the square of both sides, right? So we square the negative x, and we square this, right? So this equals x squared, right? Well, negative x squared, which is just x squared, right? So x squared equals 6 squared, because remember, in these kinds of situations, right, if we look back over here, this 2, or this, like raising this to the power of 2, is doing this to both of these, right? So the reason why this is 6 squared is because this is where this squared is coming from, right? So this is 6 squared times the square root of 2x squared, and the reason why we did that is because the square root of 2x squared is going to cancel out, right? Like this this piece here, like the square root and the square are going to cancel, right? So it's just going to leave us with 2x. So in other words, x squared equals 36 times 2x. Right? And now we just got to simplify it from here. So x squared equals 72x, right? We just multiply these numbers together, and then we move the 72 over because we have a quadratic, right? We have a second degree function. We have to set it equal to 0. So x squared minus 72x, when we subtract 72x from both sides, equals 0. We can pull out an x from each of these, right? Pull out an x from x squared, pull out an x from here, and we'll get x times the quantity x minus 72 equals 0. And so now we know, well, x equals 0 and x minus 72 equals 0, right? Which means that x equals, right, if we like simply finish this off, right, x equals 0 and x equals 72, right? And now we'll plug both of these in down here, okay? So we have 0 plus 9, the square root of 0 plus 9, minus 2 times 0 equals 3. In other words, 9, the square root of 9, which is 3, the square root of 0, which is 0. So 3 minus 0 equals 3. This all checks out, right? So now we have here 72 plus 9, which is going to be 81, right? The square root of 81 is 9. And then over here we have 2 times 72, which is 144, right? And then the square root of 144 is 12. So 9 minus 12 is negative 3, and negative 3 does not equal 3. So 0 works, right? The 0 worked, the 72 did not. So 72 is extraneous, and our answer, the only answer, is x equals 0. So for all this, right, this was all one problem, right? It's been a while, but like I said, you just got to kind of keep working it. So, and there's little skills that you learned in the past, like foiling, adding radicals, like little things like that are imperative for these kind of things. So if at any point in this those kinds of things threw you off, just come see me, right? So I can explain to you how those work, okay? But the idea is that we isolate the radical, we square both sides, we isolate the other radical, we square both sides, we get our answers, right? And then we just check for extraneous solutions. All right, last problem. Solve a radical inequality. So, the body surface area, otherwise known as BSA, of a human being is used to determine some doses of medication. The formula for finding BSA is this. So BSA equals the square root of h times m over 3600. Okay. Where h is the height in centimeters and m is the mass in kilograms. Okay. So it's the height times the mass up there. Solve the equation for mass. What must the mass of a person be with a height of 160 centimeters and a BSA less than, greater than 1.9? Okay. Okay, so let's just, first of all, it says solve for mass, right? So let's solve for mass. So if we have BSA, right, I'm just going to like further this. So BSA equals the height times the mass. This is the square root, right, over 3600. All right, so the first thing you have to do in this equation would be to square both sides, right? There's not really anything else we can really do. So square both sides, and we're going to get whatever our BSA is squared equals h times m over 3600. And remember, we're solving for mass, right? So let's go ahead and multiply both sides by 3600. And this also is times 3600, right? Just multiplying it. So this is going to give us 3600 times our BSA squared equals h times m. So far, so good. So now we're just going to divide both sides by h and divide by h. And this area over here is going to equal m. So we're going to get 3,600 times BSA squared over h equals m. Okay, we solve for mass, right? What must the mass of a person be with a height of 160 and a BSA less than 1.9, right? So let's go ahead and do it. So if we know that the height is 190 centimeters, right? And the BSA is 1.9, we can kind of plug those two things in real quick, right? So let's just do that. Okay, so we have 3,600. We said our BSA is, well, it has to just, the answer is just going to have to be greater, right? So 1.9. So we can just plug in 1.9 here, squared, over our height, which we determined to be 160. Okay. So, I mean, if you were doing this in your calculator, right, the way that, I mean, if you have a better calculator, you could probably just plug this all in. But I would just do like the 1.9 squared first, right? And you get like 3.61. So now it's just a matter of numbers, right? So it's going to be 3.61 times 3,600. Take that answer, divide it by 160, and you get 81.225. So 81.225 equals the mass. Now, this is the mass when the BSA is less than 1.9 and the centimeter, it's 160 centimeters. So in other words, if we're interpreting this, right, then we would have to make sure that we understand what this question's asking, right? So basically, what does the mass have to be? The mass has to be less than this, right? Otherwise, the dose wouldn't work, right? In other words, the dose here, right? If we have a person that's this tall and we know that their BSA is less than 1.9, we know that the mass of the person has to be less than this. Otherwise, we wouldn't be giving them enough of a dose, right? Because we can kind of plug that back in. And that's what I mean when I say, like, when it comes to inequalities, we're more or less solving the problem, and then we're going to interpret what the less than means, right? Okay. Yeah, so that's it. So what we did is we started off by just kind of doing basic formulas, right? We solved for equations using radicals. We learned how to take the square root of something or square something to negate each other out. And then we rewrit formulas here using our Golden Gate Bridge problem. And then we identified extraneous solutions by plugging everything back in. We talked about why extraneous solutions exist in the first place. We solved equations with rational exponents. So in other words, if we have fraction exponents, we can multiply by the reciprocal to kind of get rid of those. And then we figured out that when you solve equations with two radicals, you just gotta kind of keep working it until it figures itself out. And then finally, we interpreted a problem that had an inequality in it. First, we rearranged the formula, and then once we rearranged the formula, we solved for m, and we determined that if the BSA is less than 1.9, then the person would have to be less than 81.225 kilograms in order to have taken that dose and it be the appropriate dose. All right, so that's it. I will see you in the next one.